here we've got another rule very similar to the trapezoidal rule. The trapezoidal rule approximated integrals using trapezoids, and Simpsons rule uses parabolas. So here, to approximate an integral, we're going to do delta x over 3, and then you're going to plug in your, those, if you think about the bottoms of the widths, you're going to plug those into the function. So only 1 times the first one, and then you'll do this pattern of 4 times 2 times 4, all the way until just 1 times the last one. And it's important here that for Simpsons rule, your n has to be even. So we want to use Simpsons rule with n equals 4 to approximate the integral from -2 to 6 of x squared e to the x. So here, I like making out what the bases would look like. So we're going from -2 to 6. Our delta x would be 6 minus a -2 over 2. So we'd get 4, over n equals 4. So we're going to get 8 over 4, which is 2. So we're going to go by 2's. Okay, so here this is our x0, x1, x2, x3, x4. Those are going to be what we're plugging into our formula. So S following this formula now, we're going to have delta x, which is 2 over 3, times plugging in our first value into our function, so -2, so we'd have -2 squared e to the -2, plus now we'd have 4. So I like writing this, so this is just going to be 1 times it, 4, 2, 4, and then 1 times it again. So now we'll plug in 0, so we'll have 0 squared e to the 0, plus 2 times plugging in 2, plus 4 times plugging in 4. Oops. It was just a coincidence that those 2 and the 4's were the same. Plus 1 times plugging in the 6. And to save you a little time watching the video, I did already do that on the calculator, and we see that here our approximation is 12,051. And if you were following from last video, you see that that's a pretty big difference from what we found using the trapezoidal rule, but notice here we're only using n equals 4. To get the best approximations, you would take a lot of, n would get bigger and bigger, would go toward infinity, but doing that by hand would be very cumbersome.